Hello everyone, this is Miss LJ. This is a set of videos I'm going to introduce to my students in IBDP physics class to talk about how to write a good IA report, okay? So I'm going to introduce this content in 4 separate videos, each focus on different part of the criteria, and I'm going to also break down this criteria to develop a checklist. Okay, so for my students and for you guys to use to check your IA report or to as a guideline to write your IA report. Okay, so before we start, let's take a look at the Physics Guide 2025, a sections about internal assessment. Over here, that criteria we will see that include 4 parts, right? So we're going to start with research question and then move on to the second part with data analysis. And as you can see that all together, it make up the total 25 mark for the IA. I'm going to start with the criteria, but this is very general, right? And after that, we're going to take a look at the checklist as well as some example that what you can do or what you should do specifically in your report to get to this margin of 5 to 6. So let's take a quick look on the research design, which is the part 1 we were going to introduce today. In this part, you will evaluate on your research questions, right, and methodologies and the descriptions. So basically, we will focus on these 3 parts at the very beginning of your report when you write your introduction, background, and methodologies. Okay, so research questions should be a specific and should have appropriate context. The methodologies with should have relevance and sufficient data to answer the question. So the methodology is appropriate and with relevant and sufficient data to support. So the description of your methodology should be very clear and focused. Let's see the criteria here. Description of the methodology for collecting or selecting data allows for the investigation to be reproduced. Okay, that means if someone see your report, he is able to reproduce your experiment by your descriptions. Okay, that means you need to communicate your methodologies very clearly and organized for your reader or examiner to understand. So these are the criteria, and we were going to break down this criteria, and I have developed a checklist for you to check when you write your background information, introductions, and methodologies. All right, now let's start with your first part of your internal assessment for the IBDP physics, which is research and design. This is a checklist that I developed for you to check whether you have included all the specific elements in your report to get a good mark in this section. Okay, so if you have finished your report, you can use that to check. If you have not, then you can take a look at this one and then try to include all the requirement or elements in your background, introductions, and design. First, let's take a look at the research questions. And of course, you should have your research question clearly stated, right? And when you state your research question, you should, whether you have include your independent, dependent, and control variable, as well as the scope of your question. A lot of you has missing the scope of the question. This is something you should pay attention as well, because if you say for the same question, if you were doing, let's take this example, what is the relationship of light intensity on the maximum velocity of a toy solar power car? This is the scope of your study, right? If the mass of the car is kept constant, so we got light intensity as independent, maximum velocity as dependent, and we got control variable, and the scope of the study is toy solar power car. And this is very specific. Tell your reader and examiner that what are the device, what types of car you were using in your study, because this gives the scope of your question as well as the scope of your conclusion. Now the second one, after you have all the variable state, and of course you need to take some time to discuss on control variable, right? And usually there will be more than one control variable in your experiment, and you should have discussions on how to control each control variable, what kind of step and strategy that you use. For example, if you're doing an experiment and then you need to keep the angle of the slope, say this is your control variable, right? So here's are the example. The angle of the incline determine the initial speed of the motor car, which also potentially affect the level of the friction, and that's why and then blah blah blah. That's why I need to control the angle of the incline angle, and then what did I use, blah blah blah. Okay, so here you state the strategy, the reason why you wanted to keep it unchanged, and what the steps that you use. After you have stated your control variables, and then the next one is materials, right? So let's look at number 3, material list. This is just something that you should done, but I just make some details on what are the things that you need to pay more attention. And usually, very often when you state your device, a lot of you just state the material but missing the range, uncertainty, right? 2 ruler, and this is ruler 1, and then this is, if you're using 2 ruler, and this would be the differences on the 2 ruler or the same ruler, whatever measuring device it is, you need to indicate the range, the uncertainty, and as well as the smallest scale. Well, from here you can see the smallest scale from the uncertainty. It will be 0.1, right? At the smallest scale, because uncertainty is half, and usually we take half of the smallest scale as the uncertainty, because when you do so, you will show in the examiner that you actually consider the accuracy and precisions of your measurements. All right, and number 4, indicate exactly how many independent variable intervals you will be testing, the range, and the numbers of the trail. Actually, a lot of students are missing this part to just indicate what is the independent variable and then how to measure. Of course, this is essential, right? But other than that, you also need to discuss the interval of your independent variable as well as the range. For example, if your independent variable is the height, h, right? Height. So that means in your experiment, you are going to change the height, right? So you get h1, you get h2, and you get h3. So you are going to get a few set of data. Let's say you are going to get 7 or 6, okay, set of data. So h here will have interval, right? Interval. Well, why it is important? Because when you design your data, you also need to think about the interval. If you are taking your interval too small, okay, so if the interval is too small, then there will not be too many differences on the dependent variable. For example, h1 will affect v1, right? h2 will have another terminal velocity, let's say, for example. So if h1 and h2 are too close, then v1 and v2 will be very close as well, right? You might not, the differences might not be significant enough for you to do the to distinguish the differences, or even the uncertainty is bigger than the differences, then that's make no point to do the investigation. If you make your interval too big, right, then if you're going to take 6 set of data, then there will be a big range, right? But sometimes when you're doing your experiment, you have limited range, so you have to take different set of data within this range. Even the numbers of trail, what kind of how many sets of data you are going to take. Are you going to take 6 set, right? You are going to take 8 set, right? Is 6 set enough for you to get reliable conclusions, and so on? So when you actually talking about this interval, range, and trails, you are actually showing the examiner that you have carefully consider this elements and doing a carefully design, and it's actually part of your design, also important part of your design, right? Number 5 is including background theory with direct relevance and hypothesis. So we all know, for this part, I'm going to use different color. Let's see, green color. Okay, so when we talk about background information, and usually you have your hypothesis state in your background, right? But here you need to get for a good IA, a hypothesis, it's based on the theoretical derivation. Okay, very often I will see a hypothesis like, for example, as x increase, y will increase, and this is very superficial, and it is not enough to get a good mark, to have a good hypothesis. So this hypothesis should have a theoretical background, and then to have some theoretical derivation. For example, over here, if you were talking about the Bruni's equation, so you got some research, right? And then you got this equation, and then from this equation, you divide and you get a equation, and this is an equation or quantitative hypothesis. Okay, it's ideally a good IA should have a quantitative hypothesis based on theoretical derivation. Okay, then this quantitative hypothesis will give you some guideline when you're doing your design. But very often, a lot of you are using a very general hypothesis. It is okay, but it will not give you a good mark. Okay, and number 6. Okay, let's look at number 6. Indicate how are you going to measure and change the dependent and independent variable. This is obviously the most important things in your design, right? So your purpose is to get H1, V1, H2, V2, and of course you need to talk about how to change H, right? How to change after you determine the interval, then what actions you are going to take to change the H and to measure the H. And when you change H, then you would change V correspondingly, right? And how are you going to measure V or to get the value of the V? But over here, just try to describe it as specific as possible for the examiner or your reader to understand what you actually did, instead of very general information like for example, I measure the height of the ink drop, for example. Okay, so instead of using, we were going to take this as example. Okay, so in this example over here, you are going to measure the temperature differences, right? So a general, and very often the general expression would be, I measure the temperature differences between 2 samples of water. But to make it more specific, you can change the word or sentence into I change the independent variables by heating water in a boiler to different temperature, and then the temperature difference between 2 samples of water measured by 2 thermometers simultaneously. Okay, rate of heat. Okay, another one. For example, the dependent variable is rate of heat transfer, right? So rate of heat transfer was measured by a stopwatch. I measure the time of heat transfer by a stopwatch, and in data processing, I get the rate of heat transfer by calculation. So this description over here describe how to get the dependent variable, which is the rate of the heat transfer. So just in a word, try to describe specifically how you are going to do that. Okay, so checkpoint 7 is, did you, when you write your background, your design, did you include the estimate uncertainty and the steps in your methodologies? Okay, it means that in your methodologies or instructions, you need to show examiner that you have take some actions and steps to um, think about your uncertainty and try to reduce the uncertainty. For example, if you wanted to say, let's look at example 2. You wanted to measure the changes in the water level, right? So during this action, there might be some uncertainty because water is kind of transparent and kind of difficult to see the water level clearly. A strategy would be dropped red ink into the water. Okay, so make the water levels more visible and clear, so your measurements in the changes of water level would be more accurate. Okay, and this is the action and steps that you took. Another example would be, say, if you wanted to measure the diameter of your hair. Okay, and some of you say, "Oh, I know, I can use micrometer, right? I use micrometer to measure the diameter of my hair very um, accurate." Now, you are smart, but not smart enough. To show that you could actually reduce the uncertainty and strategy, the steps that you could take is instead of measuring one hair, so you could measure, say, 50, right, of your hair. Okay, and then this, so 50. And then you measure the diameter of this bunch of 50 hair, the diameter of the hair here from A to B, and then you divide it by 50, okay, to get the average value of the diameter of your hair. So that's what we call multiple strategy, which can be used in a lot of measurements in a very small quantity. And these are the example of how you include some actions and steps and show examiner that you have considered the uncertainty in your design. All right. Now let's move on to checkpoint 8, which is also very important, is try to include and highly recommended to include a diagram and annotated photograph in your paper. It helps you to describe the procedures and design of your method, and this will help a lot to increase or to get your communications more clearly. And as we say, communication is also another part of the evaluation, right? So label, if you can't draw the diagram, you can take a picture and annotate it, your picture, and then use this diagram to describe and communicate. All right. Checkpoint 9, indicate how you will take each measurement and with which measuring device. When you mention which measuring device, you are actually telling the examiner that you have considered the precisions of your measurements, right? See, this whole paragraph is a description of how to measure the height. You might have seen a lot of students or will write, "I will measure the height of blah blah blah," but look at here. I fixed the long range rulers on the wall using tape. I made the ruler perpendicular to the floor as shown in the figures, and then the zero scale side of the ruler touched the floor so that I could easily read the height of the dropper. Okay, so this is example of how to measure the height of the dropper. Clearly communicate how you are going to do that and what measurements you use, and this is way much better than the previous or than the simple description of I measure the height of the dropper, because this paragraph shows examiner you consider the precision, you consider how to avoid the uncertainty, and you consider a lot of things in this action. Okay, and number 10, checkpoint 10, consider any safety and ethical issues of your experiment, especially when you're doing the chemistry or biology, and there might, and some of the physics experiment, there might be some safety issues, right? So you can always think of something of about safety and ethical issues of your experiment, but need to include this in your report. Okay, even though there is nothing harmful or very safe, at least you can say, try to avoid the disruptions to the others or clean up any possible disposal, okay, and etc. Because if you do not include this in your report, and it shows that you have no consideration at all, and which might affect your designed mark. All right, that will be the whole checklist for research and design part. And I hope this video can be a helpful instructions for you. And for the next video, I'm going to introduce and focus on how to do the data analysis. And we will see you soon. Bye.